Today, we will be starting with Unit 5.0 through 5.7. Everything in this unit will be on next 9 weeks. None of this will be part of this 9 weeks grade. So let's get off to a good start. We're starting with Unit 5.0. It is solving systems of equations by graphing. Determine whether each ordered pair is a solution of line 1, a solution of line 2, a solution of both, or neither. So it gives us line 1, and line 1 is y equals 3x. Line 2, y equals 2x minus 2. We've done some of this already, so very simply, all you need to do is acknowledge which is which. We know that this is x value, and this is y. So let's get our equation, and our equation is y equals 3x. All you're going to do for this one is substitute 2 for y. So here we're going to put 2 equals, and 3 times this 2. So our answer is 6 equals 2. That is not true. Not a solution, so put a slash through your line. Let's try the next one. Here, line 2 for the same thing. We're going to plug in. So here we have y equals 2x minus 2. Go here, plug in. For y, we have 2. Bring down this 2. For x, we have 2. Plug it in. Minus 2. So 2 times 2 is 4. Minus 2 is 2. 2 equals 2. So here, this is a solution for line 2. So note line 2. Solution. All right, now let's go to this one. -2, 6, and -2, -6. So once again, we're going to plug in line 1. We have y equals 3x, and I'm just going to drop down here. So I have y equals 3x. Plug in. We know this is x. This is y. So y is -6 equals 3 times -2. And that gives us -6 equals -6. So we know it's a solution for line 1. Let's see if it's also a solution for line 2. So we have y equals 2x minus 2. Plugging in -6 for y. equals 2, plugging in -2 for x, and it gives us 2 times -2 is -4. -4 minus 2, which is a -4 plus a -2, gives us -6, equals -6. All right, so it's a solution for both. So here, now let's look at this last one. How about you pause the video and you try it? Come back and see if your answer is the same. All right, so is this what you got? Once you plugged in your 6, it is a solution for line 1, but it's not a solution for line 2. Now, if you're not sure how to work this, please ask questions. One more time, if you are not sure how to work this, please ask for help. All right, now let's look here at our systems of equations. A system of equations, all that is a set of 2 or more equations with the same variables. Now, we saw this earlier, something like this or something like this, and there's another one that we're going to see. With our systems of equations, we're going to deal with 2 things, consistent and inconsistent. With your highlighter, I need you to highlight systems of ugly color. The color isn't ugly, just the wrong color. Highlight systems of equations here. Highlight consistent. And we're going to highlight inconsistent. These are our definitions. And I need you to underline that definition. System of equations, a set of 2 or more equations with the same variables. Consistent. It is a system of equations. Note, it is part of the systems of equations. It has at least one ordered pair that satisfy both equations. So I need you to highlight after you underline at least one ordered pair. I have no clue why this is not doing what I want it to do. All righty, so that's probably why. Let's see. At least one ordered pair, which means it can be more than one. We'll get into that one later. Inconsistent. It is a system. You've underlined it. It is a system of equations. No ordered pair satisfies both equations. I need you to put in parentheses over on the side. I need you to write no solution. Inconsistent is no solution. Come up here to this one, and you're going to write one solution or infinite solutions. All right, it's either going to be one solution or it's going to be infinite solutions. That is consistent. I know the words are new to you, but let's keep going and let's make an application. Also, let's highlight no ordered pairs for inconsistent. Here it says learn. Today we will learn graphs of systems of equations. I need you to highlight if a consistent system of equations has exactly one solution, it is independent. So here we're dealing with consistent. So here, consistent system has exactly one solution. It is independent, independent. Here, I need you to underline that also. Underline exactly one solution, independent. Next one says, and we're getting ready to highlight again, if a consistent system of equations has an infinite number of solutions, it is dependent. The graphs are the same line. This means there are unlimited solutions. So here, consistent has infinitely many. It is dependent. Underline, infinitely many. It is dependent. The graphs are the same line. The same line. Unlimited solutions. All right, next is a system of equations is inconsistent if it has no ordered pair that satisfy both. The graphs are parallel. We've seen those today, so let's highlight it. All right, so now we've got some new words here. I need you to pay attention to those words. The key that I need you to understand, and let's do another underlining and circling, is this is consistent. All of this is about consistent. Your consistent is either independent, meaning you have one solution, kind of like a parent. They are independent. One solution, they can go to themselves for what they need. Or it is infinite, meaning dependent, meaning you have many solutions. So you are the dependent. There are a lot of different people that you can go to ask questions, get answers. But this one here, we have inconsistent. Inconsistent means no solution. All right, let's look at what we're talking about. Use the graphs to determine the number of solutions the system has. State whether the system of equations is consistent or inconsistent, and if it is independent or dependent. So first of all, let's look at it. Here we have y equals negative 3x plus 1, y equals x minus 3. So they show us what our y equals negative 3x plus 1 line looks like. It's the blue one. And our y equals x minus 3 line looks like this. We can see that they cross right here. So we automatically know that they have how many solutions? Exactly. So it's one solution. And what is that one solution? That one solution is 1, negative 2. Now, looking up here, because it asks us, and we should have underlined or highlighted. So let's come back here real quick. Here, what are we supposed to do with this?
Please stand for the pledge of allegiance.
So again, we said this is 1, negative 2 is our solution. Now let's look at our notes. Oh, wait, we're supposed to underline something here. So here it says, use the graphs to determine the number of solutions. So first we had to determine the number of solutions. Then we had to state whether it is consistent, inconsistent, and independent or dependent. Now, it can only be independent or dependent if it is consistent. If it's not consistent, it can't be those guys. So let's look up here. We say it has one solution. So looking up here, it tells us consistent, at least one ordered pair. Right here, exactly one solution. So therefore, we know that this is consistent. And now that we know it's consistent, it is what? Consistent, we have these two to choose from. Independent, because it's one solution. Consistent and independent. Okay, next, let's look at example number 2. And if I'm going too fast, you stop this and slow it down or pause and think it through. All right, here we have parallel lines. Okay, come on. Which one told us about parallel lines? This one right here. So it says inconsistent has parallel lines. So since it's parallel lines, then we know without a shadow of a doubt, just like it states, that this is inconsistent. But what else do we know? Since they are not touching, since they are not agreeing, then we know that the number of solutions here was no solution. All right. So those were our two lines, the y equals 1/2 x plus 2, blue line, and the y equals 1/2 x minus 1, the orange line. All right, as we continue moving here, it says we're going to learn solving systems of equations again by graphing. You can solve a system by graphing each equation carefully on the same coordinate plane. Every point that lies on the line of one equation represents a solution of that equation. Similarly, every point on the line of the second equation is a system, represents a solution of that equation. Therefore, the solution of a system of equations is the point, highlight. It is the point at which, right? The solution of a system is the point at which the graphs intersect. What that means is everything on this orange line only belongs to orange. Everything on the blue line only belongs to blue. But when they cross, then that point belongs to both of them. For example, this solution, well, -1, 3, that is the point at which the graphs intersect, because the point of intersection lies on both lines. The ordered pair of satisfies each equation in the system. All right, so let's go on down to our example 3. We have example 4, and then we have example 5. So let's talk about how to graph these guys. All right, so here it says, graph the system and determine the number of solutions. Come on, let's underline. Graph, determine number of solutions. If one, determine coordinates. All right, remember how to graph it. Step number 1. Remember, our step number 1 was to do what? Exactly. Step 1 is to find the y-intercept. Step 1, find the y-intercept. So let's go ahead and find y-intercept for this one is 2. And that one's going to be my purple one. So we found 2. Now, it says rise over run, slope to graph other points. So it looks like it's a positive slope. So we know we're going to be going up when we finish. So we have up 1 over 4. 1, 2, 3, 4. Mark it. Over here, do the opposite, except we're going down 1 over 4. 1, 2, 3, 4. Good. Draw your line through it. Point your arrows. and label it. Okay, next, let's graph this one. Again, find the y-intercept. Let's graph it first. It's going to be our orange. Marking it here. Y-intercept, -3. Says rise 3. It's also positive. Rise 3, 1, 2, 3, and run 2, 1, 2. Rise 3, 1, 2, 3, run 2. Hey, they meet right here. So let's draw that line. And look at where they cross. So they're crossing here. And what point is that? That point is 4, 3. So here, graph, we did that. Determine the number of solutions. It's one solution. And if it's one, determine its coordinates. So here we have one solution. And that one solution is 4, 3. All right, next one. It says graph and solve a system of equations. Graph the system, determine the number of solutions it has. If it has one solution, determine its coordinates. So let's do some underlining here. So what are we doing? We're graphing, and we are determining the number of solutions. If one, determine the coordinates. All righty, so hey, what did we learn? We talked about lines and slopes. What do you notice about these two slopes right here? Yes, they are the same. And when it has the same, what kind of lines do we have? Come on, you know this, you know this. Okay, let's scroll back. Kind of lines it has is parallel lines, parallel lines. All right. So looking here. So let's go ahead, once again, follow these steps. So we have find the y-intercept. Y-intercept is 6. Hey, it's off the page, but that's okay. Find it. It's 6. Now, instead of going up, let's go down. Let's go down. 1, 2, 3. It has a positive slope over 2. 1, 2. Down 3. 1, 2, 3 over 2. 1, 2. Let's draw our line. And the next one, -2. We found our y-intercept. It's here. Using slope, rising, 3. 1, 2, 3 over 2. 1, 2. We're marking it. Up, 1, 2, 3 over 2. We're marking it. We could go down also, 3 and over 2, marking it. Let's draw our line. All right. So we can see these guys are parallel. And how many solutions we have? Exactly. It's no solution. So let me ask you this question. Is this consistent or inconsistent? Inconsistent. I know I didn't ask, but let's put it anyways. Awesome, awesome. All right, so now the next one says, write and solve a system of equations. Denzel is starting a food truck business to sell gourmet grilled cheese sandwiches. He has spent $3,400 on a truck, equipment, permits, and other startup costs. Each sandwich cost about $1.32 to make, and he plans to sell them for $7. All right, now here we are making two. One more time. Here, we are making two equations. It tells us to write and solve a system of equations. We're making two of those guys. All right, so here, how many sandwiches, write and solve? How many sandwiches does Denzel need to sell to start earning a profit? That is the question. And to earn a profit, that means he needs to get past 3,400. So X is the number of grilled cheese sandwiches sold, and let Y be the total cost of your revenue. So if Y is the total cost of our revenue, and this one is about costs, and M equals 132, B equals 3,400, let M equal 7. All right, so let's see how to write this. So they've already given us the information. Our total cost, it says Y equals our slope. It's 132 for the first one. Why? Because this is our total cost. How much are we spending? So here we are spending, let's make that a smaller. Here we are spending $1.32 for each sandwich. And X represents our sandwiches, plus $3,400. We've already spent that. Now, the revenue is, M is going to equal 7. Why? Because we're going to sell those sandwiches for $7. All right, what does that mean? That means he made the sandwiches for $1.32, but he's going to sell them for $7. All right, so we're going to graph in a calculator to identify the intersection. All right, you should be able to do this in your calculator. And once you do that, then what answer do you get? I need you to write it right here. All right, now, once you finish the sheet, the video, your next sheet that you are going to is this one. Make sure you put your name on it and the date. It says determine the number of solutions the system has. That's underlined. Determine the number of solutions. State whether the system is consistent or inconsistent, independent or dependent. Here's something I need you to remember. Consistent, let me highlight that bigger. Don't turn this off yet. Consistent is the only thing that goes with independent and dependent. It cannot be inconsistent in this. Independent and dependent only goes with consistent. So using your notes, I need you to complete this assignment. If you have any questions, make sure you ask.